Hello, welcome back once again. Today we have this weird looking integral and we're going to evaluate this integral in this video, okay? So this integral, let's call it I. We have the integral from 0 to infinity 1 all over this quintic expression x to the power of 5 plus x to the power of 4 plus x cubed plus x squared plus x plus 1 dx. So how exactly can we tackle this problem? Okay, let's get started. Maybe let's start with a substitution of letting x equals 1 all over u. Maybe that thing will give us something really nice, okay? So let's do that. Let x equals 1 over u, right? So we actually know that this also implies that u is equal to 1 over x. So from here, differentiate both sides, we get dx is equal to negative 1 all over u squared du. Now let's talk about the limit of integration. So I is equal to the integral. Now we know that u is equal to 1 over x. If x is approaching 0, u is approaching 1 all over 0, which tends to infinity, right? Now if x is approaching infinity, u is approaching 1 all over infinity, which tends to 0. So here we have 1 all over. So x cubed is going to be 1 over u cubed, right? I mean x to the power of 5 will be 1 over u to the power of 5 plus x to the power of 4 will be 1 over u to the power of 4 plus x cubed will be 1 over u cubed. X squared will be 1 over u squared. X will be 1 over u and then plus 1, right? And here the x will be negative 1 over u squared du. Are we making any progress? Yes, of course. Okay, now let's use this nice property of integral. We know that the negative integral from b to a of f of x dx is equal to the positive, then switching the limit from a to b of that same function of x dx. So use this, we can switch the limit of integration and then the negative sign will vanish, right? So that will let us know that our I is equal to the integral from 0 to infinity. So here we're going to have 1 all over, oh sorry for that. So we're going to have 1 all over. Now check out 1 over u to the power of 5 plus 1 over u to the power of 4 plus 1 over u cubed plus 1 over u squared plus 1 over u plus 1. The common denominator will be u to the power of 5, and then we have this u to the power of 5 plus u to the power of 4 plus u cubed plus u squared plus u plus 1. Then everything will be divided by u to the power of 5. And here we have to multiply by 1 over u squared and we have our du. Now we know we can flip that fraction at the denominator, and this will give us the integral from 0 to infinity. So that will become u to the power of 5, then divided by u to the power of 5 plus u to the power of 4 plus u cubed plus u squared plus u plus 1. Then multiply by 1 over u squared and then du. So we know that this u to the power of 5 will be divided by u squared, then giving us u to the power of 3 at the numerator. But remember, u is a dummy variable, so we can change that to x, right? So the integral from 0 to infinity, then we have x cubed divided by x to the power of 5 plus x to the power of 4 plus x cubed plus x squared plus x plus 1. Then we have our dx, right? Okay, now is there any progress with this? I think it is looking more complicated, right? But there's a nice progress. And what's that? Do you think about adding the two i's together? That is saying I plus I will be equal to the original integral, the integral from 0 to infinity of 1 all over x to the power of 5 plus x to the power of 4 plus x cubed plus x squared plus x plus 1 dx plus this I here, that is integral from 0 to infinity of x cubed divided by x to the power of 5 plus x to the power of 4 plus x cubed plus x squared plus x plus 1 and then dx. Now notice that we have the same denominators, right? So we can easily add the numerators. So we get here 2I will be equal to the integral from 0 to infinity. So up here we now have x cubed plus 1, then divided by x to the power of 5 plus x to the power of 4 plus x cubed plus x squared plus x plus 1 dx. Then the question here is, how exactly does this really help? So this really helps because this denominator here can be factorized. Okay, so let's do this. We have x to the power of 5 plus x to the power of 4 plus x cubed plus x squared plus x plus 1. So we can regroup this as x to the power of 5 plus x squared. Cool, right? Plus x to the power of 4 plus x cubed plus 1. So here x to the power of 5 plus x squared is common, take it out. Then we have x cubed plus 1. X to the power of 4 plus x is common, so take it out, we have x cubed plus 1. Then here we have plus x cubed plus 1. Now we can say that x cubed plus 1 is common, so we can take it out. And when you do that, we're left with x squared plus x plus 1. Isn't that not amazing? It is indeed awesome. So now, we have our 2I is equal to the integral from 0 to infinity. So we have x cubed plus 1 divided by this product x cubed plus 1 multiplied by x squared plus x plus 1. Then we have our dx. So nice cancellation. Oh my god, this is indeed a magic, right? So we now have 1 over x squared plus x plus 1 and then dx, which we know that this now we can easily evaluate that, right? Okay, cool. Now we can actually say 2I is equal to the integral from 0 to infinity. So that will be 1 all over. So we can write that as x plus 1 over 2 whole squared plus 3 all over 4. That is how to complete. That is the expression in a completed square form, right? So what can we do? Let's recall that the integral of 1 over x squared plus a squared dx is equal to 1 over a multiplied by the inverse tangent of x divided by a plus c. So we need this denominator to look like this, x squared plus something squared. So how can we achieve this goal? This is what we're going to do. So this is equal to the integral from 0 to infinity of 1 all over. So we have x plus 1 over 2 whole squared plus, so that will be root 3 divided by 2 whole squared. Then dx. Did you get the idea? So actually we can make a use substitution of x plus 1 over 2, but to cut the long story short, we know that the derivative of x plus 1 over 2 is just 1. So we can just make use of that formula immediately. So get 2I is equal to, so that will give us 1 over root 3 over 2, which is same as 2 all over root 3. Then the inverse tangent of x plus 1 over 2 divided by root 3 over 2. Right, then from 0 to infinity. We can simplify, right? So we have 2i is equal to 2 divided by root 3. The inverse tangent, remember this fraction here can be flipped, right? So that will be 2 multiplied by x plus 1 over 2, then divided by the square root of 3. We have a limit from 0 to infinity. So here we have 2i is equal to 2 divided by the root 3. The inverse tangent of, so this will give us 2x plus 1. Then divided by the square root of 3 from 0 to infinity. So here we can divide both sides by 2. We get I is equal to 1 over root 3 into bracket, put the upper limit. That will give us the inverse tangent of infinity, minus, put the lower limit. That will give us the inverse tangent of 1 over root of 3. Okay, so from here now, we have I is equal to 1 over square root of 3. So here, inverse tangent of infinity is pi all over 2, minus the inverse tangent of 1 over root 3 will give us pi all over 6. So this will give us 1 over root of 3. So pi over 2 we can write as 3 pi over 6, then minus pi over 6. So you can see we have the same denominator, right? So here I will be equal to 1 over root of 3. So 3 pi minus pi will give us 2 pi, and then we have over 6, which we have here 1 over root 3 multiplied by 1. Oh, okay, so that is pi, right? So pi over 3, which finally gives us our right answer as pi divided by 3 root of 3. So we can say that our integral from 0 to infinity of 1 divided by x to the power of 5 plus x to the power of 4 plus x cubed plus x squared plus x plus 1 dx is equal to pi divided by 3 root of 3. So this right over here is our solution. Please, if you really enjoyed this video, please kindly support this channel by subscribing to this channel. Please do not forget to subscribe. Also like, comment, and share.